In this module, we will talk about the third part of the oxygen delivery system. First part was the compressor, second was the air sterilization system, and the third one is the sparger. What is sparger? And what is the role in oxygen delivery system? The air sparger is used to break the incoming air into the small bubbles. So when there is a stream of the air coming through compressor and then enter through air sterilization system and then enters into the fermentation medium, so there are the small pores or the slit, either that have a round, either there may be a slits. So there are different design and the shape of the spargers. In a daily life, you can see the stove. So how the gas, natural gas, comes out from your stove. So you have a different design and different shape of that, just to give a equal distribution in the whole. So by the same way, in fermentation system, the sparger having the equal distribution of the air into the fermentation vessel and giving a proper size and the shape of the bubbles. So in case of the porous sparger, sometimes the sparger is a slit-like. So there are the different types. So we can say that the sparger is basically the device that control the bubble size. But later on, these bubbles can be further having the link with the impeller system, as we have talked about while talking the agitation system and their role of radial impellers and axial impellers and what are the shear effect to creating the bubble size. But the sparger has its own role for making the bubbles properly and equally distributed into the fermentation medium. So in this slide you can see that here you can see there is a sparger, and that having 1, 2, 3, 4 and 5 different points from where the air can oozes out. And the upper to this aeration sparger, then there is a impeller agitation system. So when the spargers facilitate to distribute the air bubbles into the fermentation media, and then that have a proper distance from the impeller system, that will control their bubbles and their distribution inside that. So that why when they collide with this system, then there is a shear effect. So that's why this whole system, aeration and agitation system, work together. As concerned the sparger ring, that should be exactly situated below the impeller. So that's why that help to have a direct contact with the air bubbles. That's why that help and to facilitate the breakdown of those impeller into the smaller size. So that is the role of placing the sparger just below the impellers. So as concerned the shear forces that an impeller generate play a major role in determining the bubble size. So if the impeller speed, as concerned the distance from the sparger to the impellers, on other hand, the speed of the impeller is also having a role in the formation of the bubble size as well as the distribution of the bubbles. So if we say, in this slide you can see that, just imagine if the impeller speed is very slow and then the air bubbles, when they exit and oozes out from the spargers, they just go and having a less time to retain inside the fermentation medium. But in case when the impeller speed is very high, what happen? Then they facilitate having the equal distribution and a proper distribution of the air bubbles. So when there is a proper distribution, and then each bubble have a maximum retaining time into the fermentation medium. So when there is a less time of the retention of the air bubble into the medium, it means then there is a less chance of the oxygen solubility. But when there is a more time retained in the fermentation medium, then there is a more chance of oxygen solubility inside the fermentation medium. So because the oxygen delivery system, the more object behind this is just to supply the oxygen demand. So if the air bubble just passes through the fermentation media just without dissolving the oxygen, then there is no need of that. So that's why it is very critical, the speed of the impellers and the pressure inside the sparger. So another consequence of the too slow impeller speed is the flooded impellers. Because sometimes when there is the slow speed, and then there is a more flood of the air bubbles, and there is a column of the air is produced, and that's also having less chance of the contact of the air bubbles to the fermentation medium. So under these conditions, the bubble will accumulate and collapse under the impeller, leading to the formation of the large bubbles. So the small bubbles aggregate to having a form, a bigger bubbles. So when there are bigger bubble, then there is a less surface area. So that's the way. So in other case, a similar phenomena will happen when aeration rate is too high. In that case, then oxygen transfer efficiency will also low. So the air pressure and then the impeller speed, these are the both factors which can either have a positive effect or a negative effect. In case of the optimum condition, then the proper working of the oxygen delivery system, along with the combination of the impeller speed in a fermentation vessel.